Introduction. Can anyone tell me what are polynomials?
A polynomial is made up of terms that are only added, subtracted, or multiplied.
Very good. And what do we call the polynomials having degree 1?
Linear polynomials.
And second degree polynomials are called?
Quadratic polynomials.
Absolutely correct. Do you know that a second degree polynomial in x is also called a quadratic equation in x? Today we will learn about quadratic equations. Come, let's see. Objectives. At the end of this lesson, you will be able to analyze the quadratic equation, solve the quadratic equations, know the applications of quadratic equations and its approach. Quadratic equations. What are the quadratic equations? The standard form of a quadratic equation looks like this: ax² plus bx plus c is equal to 0. The letters a, b and c are coefficients. They can have any value except that a can't be 0. The letter x is a variable or unknown. Let's take an example. 2x² plus 5x plus 3 is equal to 0. In the above equation, a is equal to 2, b is equal to 5, c is equal to 3. From the fundamental theorem of algebra, we can deduce that the quadratic equation has two roots. Quadratic equations. How to solve the quadratic equations? The roots for the quadratic equation: ax² plus bx plus c is equal to 0 are the value b² minus 4ac is denoted by the term discriminant d. That means d is equal to b² minus 4ac. 1. If d is equal to 0, then the quadratic equation has one real root given by x is equal to minus b by 2a. 2. If d is greater than 0, then the quadratic equation has two real and distinct roots given by x is equal to minus b plus minus under root d by 2a. 3. If d is less than 0, then the quadratic equation has two non-real and complex roots given by x is equal to minus b plus minus iota under root minus d by 2a, where iota is imaginary number. Example. Solve the equation for x. x² plus 12x plus 36 is equal to 0. Solution. Coefficients are a is equal to 1, b is equal to 12, c is equal to 36. d is equal to b² minus 4ac. d is equal to 12² minus 4 into 1 into 36 is equal to 0. As d equals to 0, so the roots are is equal to minus 12 by 2 into 1. Now solving, we get is equal to minus 6. Example. Solve the equation for x. 5x²
plus 6x plus 1 is equal to 0. Solution. Coefficients are a is equal to 5, b is equal to 6, c is equal to 1. D is equal to b square minus 4ac. D is equal to 6 square minus 4 into 5 into 1 is equal to 16, as d greater than 0. So the roots are is equal to minus 6 plus minus under root 16 by 2 into 5 is equal to minus 6 plus minus 4 by 10. On solving, we get is equal to minus 1 minus 0.2. Example. Solve the equation for x. 5x square plus 2x plus 1 is equal to 0. Solution. Coefficients are a is equal to 5, b is equal to 2, c is equal to 1. D is equal to b square minus 4ac. D is equal to 2 square minus 4 into 5 into 1 is equal to minus 16. As d is less than 0, so the roots are is equal to minus 2 plus or minus iota under root 16 by 2 into 5 is equal to minus 2 plus or minus 4 iota by 10. On solving, we get is equal to minus 0.2 plus or minus 0.4 iota. Did you know? The Indian mathematician Brahmagupta is considered to be the first man who invented the quadratic formula as modern people know it today. Quadratic equations not only described the orbits along which the planets moved around the Sun, but also gave a way to observe them more closely. Summary. Let us summarize what we have learned. The standard form of a quadratic equation looks like this: ax square plus bx plus c is equal to 0. The letters a, b and c are coefficients. They can have any value except that a can't be 0. The letter x is the variable or unknown. The quadratic equation has two roots. The value b square minus 4ac is denoted by the term discriminant d. If d is equal to 0, x is equal to minus b by 2a. If d is greater than 0, x is equal to minus b plus or minus under root d by 2a. If d is less than 0, x is equal to minus b plus or minus iota under root minus d by 2a.